Okay. So our agenda. So we had our community meeting. We are going to review the arithmetic sequence formula, because that is where we left off on Monday. So we're going to start from there, because remember, we had a proposal on what the term we are looking for would be. Then we are going to talk about the geometric sequence formula, and then we're going to do a little bit of practice. Okay? All right, so this was our warm-up the other day. And again, this warm-up just reignited the difference between an arithmetic sequence and a geometric sequence. And then remember, the other alternative is neither. The sequence may not fit a pattern at all. And if it doesn't, that's okay. It is just neither geometric or arithmetic. Okay, so that was our warm-up the other day. So, bam, this is where we ended. So, we are normally given a sequence. We are asked, what is the difference? You are looking for the pattern. Once you find the pattern, you create the next three terms. I agree, it's beautiful. But sometimes you are asked a term that's further down in the sequence. Okay? So our proposal was for you to find, or the question was for you to find the 20th term of the sequence, which means you had to use the formula. So from the formula, we remember that the A means the first term of the sequence. D is the difference. So D, our difference was 4. And then N is the term number. What term are we looking for? So we are looking for the 20th term. We never figured out the answer, but the proposal before we left was 95. So today we are going to start there. I want you to put the values of the variables in their proper places. Remember to use order of operations to solve, and tell me what the 20th term is. I am going to give you 3 minutes. I have 11:01. So again, let's put it in its proper place, and we will.
Wait, what was the question, Ms. Hicks?
The question is, what is the 20th term of the sequence? So we have 1, 2, 3, 4, 5, 6, 7. We have 7 terms. We want to know the 20th term. So the question in the other class I posed was, so do you continue adding 4 for 13 more times, or would it be easier to use the formula? Okay, so we had gotten to the point where we figured out the pieces that go into the formula. My question to you is, was that projection or that proposal of 95 being the 20th term true or false? So that's where we are right now.
I think it's true.
You think it's true? All right, well, let's put it in the formula, and let's see, because that's what we're going to do. All right. So again, let's see what happens, darlings. All right, so if this is our formula, no other proposal? We say 95 is it? Okay. We shall see. X n equals A plus D n minus 1. All right, so Let's see what we have, darlings. No. All right. So now, so this is our formula. So I want somebody to walk me through. Let me take out this space here. Okay. Walk me through. What's the next step? Again, to the right, you have your pieces. And again, we try to always line up the equal sign so we can watch the problem unfold. So what is our value of A? What is the first term of the sequence?
3.
All right, bam. So we got 3. All right. And what is our value of D? What is the difference?
+4.
Yep, it's a +4. So we don't need to bring the plus with us because we already have a plus. I'm there. All right. And then boop, boop. What is our value of N?
And 20 your turn, right?
20. Yes, it is. Okay.
All right.
So now, all right. So what we have so far is we took the equation we had. We have picked out all of the variables and their values. So we just did a substitution. So we replaced every variable that we could, excuse me, with its proper value. So now, do the math, ladies and gentlemen, and tell me if it comes up to 95. And again, I will always show all of the steps. You do not have to do that. However, if you need to, do what you need to do. Did we come up with 95?
I'm still sticking with my answer.
Okay. All right, let's see. Let us see, darling. All right, so we got 3. Plus. All right, so we haven't used the 4 yet. Order operations. 20 minus 1 is?
19.
Thank you. All right. Let's keep it rolling. Order ops. We keep that 3. We have not gotten to the addition yet. What's 4 times 19?
76.
76. So lastly, we now have So the 20th term of the sequence, excuse me, oops, the format switched up. Oh gosh, it went in the wrong place. I'm sorry. Take that out. Undo. All right, let me go back here. Sorry, I messed up the. All right, now. Okay. So the answer should have been 79. So the 20th term is 79. So my question is, when you look back at the problem, what happened? Did you remember your
Not
order?
on the window.
Oh, okay. All right. So yeah, so you may see now what happened. But order operations, remember, parentheses, we had to do that first. So that's how we got to 19. Then from this, we did parentheses first and got here. Remember, the multiplication comes before the addition. So we had to do this multiplication first, giving us the 76. Then we go back and do the addition last. So the 20th term in this sequence is 79. Okay? So again, first, do the substitution. Replace as many variables as you can with their proper value. And then do order ops. All right, so, excuse me. All right, sorry about that. My hay fever is acting up. All right, so now, just like we have a formula for an arithmetic sequence, and again, those of you who are writing your notes, I'm going to leave it there. Okay, those of you who are taking a screenshot, make sure you take a screenshot. So again, just like in an arithmetic sequence, again, you may be asked a term further down in the sequence. So for an arithmetic sequence, we have that formula. But for a geometric sequence, here is the formula. So now, again, same steps, but as in a geometric sequence, how the sequence moves is by a ratio, whereas in a geometric sequence, it moves by a difference. The difference could be positive or negative. In a geometric sequence, it moves by a ratio, and a ratio is just a non-zero number. So that means it can be a fraction or it can be a whole number, okay? And again, same thing. Let's find the next 3 terms given this sequence, and then find the 11th term. And here you see your possible variables. See if you can pick out the variables and find the 11th term. So first, let's talk about the ratio. How is the sequence moving? You started with 4. You did something and you got 12. You did that same thing to 12 and got 36. You did that same thing to 36 and you are now sitting at 108. How is the sequence moving? What's the ratio?
Times 3.
3. Yep. Okay. So now that we know it's times 3, tell me the next 3 terms.
324.
320, wait, 324. I heard you, but my fingers couldn't get there. Go ahead.
972.
972.
2.
And what's the last one of the 3?
2,916.
2916. Okay. So now those are the next 3 terms. But again, we want to find the 11th term. So A, just like in so what you get for your value of A? What you thinking? Think about what A was in the
4.
A is 4. Yep, because that's the first term of the sequence. All right. What is R? Remember, R is the ratio.
Times 3.
Yep. So you multiplying by 3. So you actually just need the number. So, okay. So 3. Oh, sorry. Yeah. So 3. And it's a positive 3. So that's good. And N. Which term are we looking for?
The 11th.
Exactly. So now, again, just like before, do the substitution and tell me what's going to be the 11th term.
200,036. Wait, oh shit. My fault.
Wait. Oh, I was going to say, hold tight. All right, I'm going to type. Wait a minute. Let me get my typing. Come on. Okay, here we go. So we have A sub N equals AR N minus 1. And here, I said to you earlier that you were going to have to remember exponents. Here they are. Superscript, okay. I don't know what that was. This is subscript. All right, so again, let's put in the pieces. So we have A sub N equals, you said A times R, and then we got N minus 1. All right. Oh. Okay, so let me put these where they belong. So format, we are going to subscript 11. Subscript 4. And we are going to make that. We are going to raise that to the power. We will make that 11. All right. So now, I guess I could have put a symbol in here. Let me change that so that I don't throw you off. All right, so ladies and gentlemen, remember when A and R are close together, it is understood that you are multiplying them. Okay, but again, we are going to apply what we know about order operations to this whole situation. Okay, so let me do it that way so nobody gets thrown off. So now, here is our formula. So we want the, whatever, this is the term is equal to the first term of the sequence times the ratio raised to the power of the term minus 1. So all of that means the 11th term is equal to 4, which we found as our value of A, times 3 raised to this power. Order of operations says we do parentheses, then exponents. So let me take this space out. All right, so let us continue with where we are here. Take the format off because it's still in superscript. Okay. So now our equal stays. We have not used 4 yet. We have not used this piece yet. So that's coming down with us. We have not used the 3 yet. And we are going to simplify. Ooh. We are going to simplify the exponent. Okay, so now we simplified the exponent. So here's where we are. So now again, order operation says we do exponents first. So can somebody tell me what is 10 to the third?
30, right?
I mean 3 to the 10th. I'm sorry.
Say that again.
3 raised to the 10th power. What you got? 3 times 3 times 3 times 3 times 3 times. So what you got? And you can help him out. He don't have to be out there by himself. Wait, because I'm using my calculator too. So,
9,049.
Oh, wait. You said 3 raised to the 10th. What you get?
9,049.
Yep. And then we are going to go a little further. We're going to go further with that. And multiply by 4. Multiply by 4. And what you get? So now we got backspace equals. Now we got our 4.
236,196.
You said 59,049. And when you multiplied that by 4, you got what? 263,000?
No, 236,000.
Oh, 200.
196.
196. So now, don't you think, even though the numbers did grow pretty quickly, but don't you think that that was a little easier than if you would have continued to multiply by 3, multiply by 3, multiply by 3, even though we are at what? This is the 7th term, but you still would have had to go 4 more. Okay, so again, same thing. We have a formula. They give us a start. Okay, we just have to plug it in to the right places, which we did here, the substitution. All we did was, after we identified the values of our variables, we went to the equation. We put in we replaced the variables with their values. And then it came down to just doing a little bit of math. We had a subtraction here because the exponent goes first and it is in parentheses. So we found that first. Then order of operation says parentheses exponents. So we did the exponent and we got 59,049, and then we multiply. So that's how we got 236,196. And that would be the 11th term of this geometric sequence. And we ended right on time because I know some of you have Spanish.
I def do. I'm going to
So,
add class now.
remember, ladies and gentlemen,